will present presence and role of Artemia and salt lakes, biology and ecology used in aquaculture. It's a nice opportunity. Our colleague Alicia was giving some indications of the environment. That's nice, and how to measure this environment with remotely sensed data. And then we are coming to the Artemia themselves.
It will be a repetition for a number of people here in the room, but I think it's important that for the complete audience that we have a short introduction on the role of Artemia, the brine shrimp. And I repeat, it will be maybe the 10th or the 20th time that some of you will hear the story, but for others it's new, and I will try to make it short. So first of all, the brine shrimp, it's a very unique extremophile, as the terminology is being used. It's a shrimp about 1 centimeter in size, living in conditions where most other organisms, particularly predators, cannot survive. So that means salinities, high salinities. So one of my questions for Alishir, when he was mentioning about saline lakes, I've seen that you consider also the Caspian Sea as a saline lake. So we will see that we have different terminologies. When we talk about saline lakes, we talk about salinities 2 and more times the concentration of seawater. But okay, this is a discussion for later. The brine shrimp Artemia is living at salinities at least twice the concentration of seawater. I need to say at least because it differs from one place to another in function of the conditions that, be it fish, be it crustaceans, be it insects, can be able to support. So you can go to salt lakes where you find Artemia at 80 grams per liter, and places in Egypt, for example, up to 150 grams per liter. You have some Aphanius fish that can survive. So one peculiar characteristic is to live where the others cannot survive, and in order to be able to survive at these high salinities, Artemia has developed unique biological characteristics. We cannot enter into all the details. One of them is the production of embryos that can be packed in a shell, about a 4,000 cell embryo. This is what we call the cysts. As you can see, less than 0.5 millimeter in diameter. And this is unique in Artemia because these cysts, they can be stored, they can be dried, and they can resume their further life 10, 50, who knows how many years later when they are introduced in proper conditions. So they live in salt lakes, and although it's an old picture that I'm showing, it has taken quite a number of years before some people realized that the brown mud that you see accumulating on the shore, that this is the cysts of Artemia. I have been to places in the world where they said, oh, each autumn we have that stuff that is accumulating. Some Japanese are coming to collect it and use it as a good soil fertilizer for orchids to hide that they were in fact collecting them for use in aquaculture, as you will hear in a moment. Important maybe for the further discussion is to have a little bit an idea on the life cycle of Artemia. So we start on the left here with the cysts, and as you heard, they can stay on the beach of the salt pond or floating on the salt lake for quite some time. When the conditions are favorable, and that's temperature, salinity, not entering into all the details here, they hatch out, and the baby Artemia is born, measuring, again, less than 0.5 centimeter in size. And within a period of a couple of weeks, I say plus minus 2 weeks, depending on Kazakhstan, Siberia, or a salt pond in Vietnam. It can be 9 days, it can be 3 weeks or 4 weeks before the 1 centimeter adult Artemia stage is reached. You see a picture here of a female. We will explain later that there are males and females, bisexual and parthenogenetic populations, not crucial at this stage. The geneticists will go into more detail. But unique of that animal is that it can reproduce by 2 ways. I have only explained one, but under good conditions, favorable conditions, most of the time in spring in the salt lakes, you see that the hatching of the cysts will establish a new population, and that population will reproduce by live offspring, producing live babies, what we call the ovoviviparous reproduction. So that means that we can close this loop for quite some time, weeks, months, and when the animals are in good conditions in terms of temperature and food, they can produce a lot of offspring over a short period of time. It can be several hundred offspring in less than a week time. Offspring that within 2 weeks, when the conditions are favorable, again become adults. So with a small inoculum, you can build a big population. And then in the salt lakes, when autumn comes, in salt ponds in Vietnam, when the temperatures or when the conditions become rather extreme, you see that under what we call the suboptimal conditions, the mother Artemia will fill the brood sac with eggs. They will start the development either after fertilization when it is a bisexual one or immediately. And once they reach a 4,000 cell embryo, then they are packed in a cyst shell, stop their development. For a long time, we thought that this was a kind of dormancy, a kind of sleeping phase. No, it is well documented now that it is a full stop of metabolic activity, released, floating in high salinity waters, blown ashore, and wait for better conditions. So the ecological characteristics, I will not go into much details if particular questions come up. High salinity, I explained it already. They have unique biological characteristics to survive in these extreme conditions. Lower salinity limit, as I explained you, is determined by the upper salinity of fish, crustaceans, insects that can survive. Very important in our later discussions this afternoon and the coming days is that the ionic composition can be very different from one salt lake to another. For a long time, we just thought, oh, these are evaporated seas, so chlorine, sodium chlorine lakes. But there are many in Central Asia that are high in sulfate, high on carbonate, and that can result in some confusion when we are comparing data on salinities. So that's why we use that Greek determination, thalassohaline, so the origin is from evaporated seawater, or the athalassohaline, where it can be carbonate, sulfate, different other ions. Okay? How does Artemia get from one side to another? Not via the sea, because in the sea the salinity is low, it would be eaten right away. So it is birds, flamingos, all kinds of water birds. We will hear in a number of the presentations that it differs from one region to another. The cysts can be carried by wind, and indeed this can also be a way of dispersion into other habitats. And then man, deliberate and undeliberate. Deliberate we will hear later this afternoon from Hoa. But undeliberate, let me just tell you a story which we didn't realize that happened already maybe hundreds of years ago. But the Spanish, the Portuguese, who were the pioneers in setting up, and I'm talking hundreds of years ago, salinas, salt works in Brazil and in other places, or even the Americans, because it was the company that was operating, the Leslie Salt Company, now the name comes back, that when they were setting up new salt works in Australia, they were seeding the salt works in Australia with salt from a good functioning salt company, like the one in the San Francisco Bay Area. And no coincidence that we find Artemia franciscana in the Dampier salt works in Australia, because it was probably by introducing that salt, carrying some of the cysts of that particular area. So dispersion can be very different and plays, of course, an important role when we talk about biodiversity of Artemia. I will not enter into the details. It's just to show you that you find Artemia all around, in of course, high saline habitats. Different species, Parissa and a number of others will go into much more detail. I've seen, and I'm looking forward to some very interesting presentations in the coming days. So now the link with aquaculture. You heard already, these cysts, they are floating, they accumulate on the shore. The Japanese were, in fact, the pioneers of the modern, if we can call that, the modern aquaculture. So they found out that to replace plankton as basic food, as starter food for be it fish or shrimp, that they could use these dried cysts, I like to call them magic powder that you can ship around the world, you incubate in seawater, and within 24 hours, you produce these baby Artemia, less than 0.5 millimeter in size, and a very suitable food for a wide range of freshwater, brackish water, marine fish, and also a lot of crustaceans. So it didn't take long before the two companies in the United States, initially for ornamental fish, but then from the 70s, following the findings of the Japanese, started to market Artemia cysts. But keep an eye here on what is mentioned. The world market at that time was even maybe just a few hundred kilos of cysts on a yearly basis. So 1976 has been a very important year, because FAO was organizing the first conference on aquaculture. And they were right, FAO was right at that time to consider Artemia a bottleneck for aquaculture. Why? Because there were only commercial available sources from the United States, and the late Dr. Ramu Pillay was indeed saying, how can we develop aquaculture in poor countries, say in Africa, say in Asia, if we need to rely on hard currency, on US dollar? And so that's where we tried to convince FAO that there were opportunities to look into other sites, etc. In 1978, we set up the Artemia Reference Center with a group of people, and I'm very proud that there are still some of the pioneers like Gonzalo from Chile that were involved in these early years of developing new techniques on how to hatch the Artemia, how to apply it. Then very quickly, and also very proud that the pioneers are also in this room here, Thomas, very proud of the work that you initiated there 30 years ago, or how many years ago? And that very, very quickly the hatchery activity of marine fish in particular and shrimp started United States, Latin America, Asia, all around the world. And the demand for Artemia very quickly went up. Other places in Central Asia, it was more labor-intensive harvesting, but also new sites. This is here the Karabugas Gol in Turkmenistan. Suddenly new sources were developed where quantities in the thousands of metric tons were discovered. So as of the 1980s, it became established that brine shrimp Artemia was a most suitable source to use in aquaculture. And today, I think we can really be impressed to realize that this is a multi-billion US dollar industry, just the production of the baby fish and shrimp, where Artemia is playing for a number of days, of weeks, a crucial role. And these were calculations by FAO. This hatchery activity is at the source of over 10 million metric tons of aquaculture produced species. So you see to the left there that over the last decades there has been a quick increase. So today we can summarize and say that the commercial sources are in the first place the Great Salt Lake, then quite a number, and we will hear different presentations, quite a number of salt lakes in, I call it Central Asia, that broad region from the west of China all the way to the Caspian Sea area. Coastal salt works, we will hear from Su Ling on also the coastal areas in China. And this afternoon there will be a brief presentation. This has nothing to do with salt lakes, but with solar salt operations that are really also from a socioeconomic point of view, for an aquaculture point of view, placing a role. Well, there are critical needs, and some of these critical needs will be addressed here in this meeting. Sustainable harvesting. You can do over-harvesting, and we are afraid that this might happen in some places. Then what is the impact of climate on a number of these lakes? We will also have a number of evidences there. And last but certainly not least, we need to be concerned about the gene pool, because it is really sad to see, last week again, papers that are being published and referring to Artemia salina. You look in the material and methods and you see that they were using Artemia from the Great Salt Lake. So from a conservation point of view, from a biodiversity point of view, it's good that we will have a session tomorrow afternoon, if I remember well, where that will be focused. So it was FAO during COVID times who took the initiative, and thank you, FAO. It was because of the fact that people were just isolated here in Rome and were looking for maybe there are other topics that we should address, and that's how suddenly Artemia became an issue where one wanted to realize if Artemia is playing such an important role in aquaculture, what about 10 years and 20 years from now? And I remember that when that question was asked, I was a bit surprised indeed. We do not think 10 and 20 years ahead. And we should, because the examples I will go very, very quickly through, because many presentations will go in more details. Karabogas Gol, at a certain moment, over 1,000 metric tons of Artemia cysts. A few years later, dry, source zero. We will hear the story on the Aral Sea. Thousands of tons, really, of Artemia cysts some 20 years ago. Okay, very, very small quantity still coming from the western Aral. Same with that big lake. The next presentation will go in detail. Urmia Lake, a big source of Artemia, finished, no longer. So it was through, let's say, that impulse of FAO that we set up a new let's say, international network called the International Artemia Aquaculture Consortium. A lot of good friends from the public and the private sector deciding to work together. To make a long story short, FAO has given an opportunity to this group to give a presentation, as we have heard in the opening addresses on the Global Conference on Aquaculture. Finally, it is now, since 2023, recognized as an entity which is hosted by NACA, the Network of Aquaculture Centers. There are 8 recommendations of IAAC. I will not go through all of them, would take us too long, but there are a few of these recommendations that should be addressed also here during our meetings. And in fact, recommendation number 1 is in fact the topic of this meeting: sustainable harvesting of the wild Artemia sources, so involving the criteria and methods that are applied at a number of places in the world. What can we learn from each other? What are recommendations that could be formulated? A second one is we should come to some guidelines some guidelines on certification. Because there is so much confusion. I told you the story, but it is not only a confusion when people are referring to the particular species they are working, but many of the farmers, be it in Thailand, be it in Brazil, that are using Artemia thinking, it is this particular source where they are using the well-described conditions for hatching and use in the Artemia manual, but not realizing which strain or species they are using. Climate change impact will also be a topic of discussion here, and a very crucial one for tomorrow is on the genetics. So thank you very much, and I think this is the biological introduction to this workshop.